This video will show you how to cross-calibrate a Chemtrack TC007 turbidity meter against a laboratory turbidity meter. Turbidity is a measurement of light scattered from a suspended particle. In liquids, this measurement is a function of concentration, particle size, particle shape, refractive index, and color. Concentration is the amount of light scattering material in the sample. The size and shape of the light scattering material in the sample will influence how the light is scattered. For oil in water emulsions, such as milk, there must be a refractive index difference between the suspended material and the medium, otherwise light would simply pass straight through the sample. And finally, the color of the sample should not interfere with the measurement of the suspended particles. It is essential to take these parameters into consideration when designing a turbidity meter. The Chemtrack TC007 turbidity meter uses a ratiometric technique that measures scattered light at 90 degrees and attenuated light at 0 degrees. A ratiometric measurement will provide excellent sensitivity for very low to medium concentration particles of all sizes and shapes. For industrial processes, this technique will measure and compensate for window fouling and sample color, providing a reliable and robust measurement. Due to the complexity of turbidity measurement and as a result of slight design differences between different products or even models of the same brand, different readings may result when measuring the same sample. In this training video, we will calibrate a Chemtrack DIN DN50 measurement cell. All the electronics are separated by optic fibers. We will cross-calibrate the Chemtrack TC007 turbidity meter using a portable handheld turbidity meter using a Formazine turbidity standard. Let's get started. Pour some filtered laboratory water into the measurement cell. You will need to use a plastic pipette to remove any air bubbles that have attached themselves to the optical surfaces. Once free from bubbles, cover the cell and start the zero sequence. A zero will automatically adjust the system for an optimal measurement. The first step will be to measure the turbidity of the water used to zero the Chemtrack turbidity meter using the master turbidity meter. In order to make a manual calibration, it will be necessary to record the ratio or the R value from the Chemtrack turbidity meter. The R value can be found in the Info General menu. As we will be using the R value repetitively throughout the calibration, a better method is to configure the display so the R value is shown continuously. Before moving to the next step, record the R value and the corresponding turbidity reading from the master turbidity meter. Before using the Formazine turbidity standard, invert the bottle at least 10 times to disperse the polymer. Never shake, as this will introduce air bubbles that will interfere with the measurement. The concentration of the Formazine standard we are using here is 4000 NTU, and will add approximately 20 drops of this to the measurement cell. Disperse the Formazine using a plastic pipette and be sure no air bubbles are attached to the optical surfaces. Cover the measurement cell, then wait a few seconds for the measurement to stabilize. When the R value has stabilized, record this value. Remove some of the solution in the measurement cell and measure the turbidity of this solution using the master turbidity meter. Record the turbidity value of the solution from the master turbidity meter. The procedure we just completed will be repeated using a higher concentration of formazine. We will repeat this procedure several times until we have a range of turbidities that will be used to make a cross-calibration between the two turbidity meters. Each cycle you will need to record the R value from the Chemtrack turbidity meter and the corresponding turbidity from the master turbidity meter. The exact amount of formazine added to the measurement cell each time is not important, only that it spans the range of turbidities that you are going to measure in the process. To reiterate, the procedure is to add formazine, stir and remove any air bubbles, measure and record the R value, measure the turbidity using the master turbidity meter and record this value, then repeat the procedure until the desired range of turbidities have been measured. For this cross-calibration, we have made a series of measurements spanning the range of 0 to 800 FTU. Note how in each case we have recorded the turbidity value from the master turbidity meter and the corresponding R value from the Chemtrack turbidity meter. Now we need to enter the values into the Chemtrack turbidity meter in order to build the calibration. The easiest way to do this is to use the web interface. Select the Calibration tab. The calibration type should be piecewise linear. The calibration source is R. Then proceed to enter the calibration data into the table. You will soon start to see how we form a calibration between the master turbidity meter and the Chemtrack TC007 by correlating the raw ratio or R value to the corresponding turbidity values from the master turbidity meter. When finished adding data to the calibration table, press Upload to send the calibration to the turbidity meter. If you are not able to use the web interface, it is also possible to enter the calibration data using the user interface on the turbidity meter. The final step of this procedure is to validate that the calibration entered is correct and that the turbidity values between the two turbidity meters read the same value for the same sample. Note that the cross-calibration demonstrated here uses formazine. We recommend that you cross-calibrate your turbidity meter using the process sample if possible, as this will have the same properties and will provide a better match between the two turbidity meters. Alternatively, Chemtrack can provide a polymer bead solution which is a safer alternative to handling formazine.